From the first part of the question, we have already deduced that if I were to take 1 over n multiplied by f1 over n, I'm going to get the area of this rectangle over here. And if I were to take 1 over n multiplied by this, which means that I'm taking this width multiplied by this height, I'm going to get the area of the second rectangle, and so on all the way until the last rectangle. And if n goes to infinity, that means the width of the rectangle will become very infinitely small. That means this can be actually calculated by doing a process of integration of the function fx. So what we're going to do to evaluate this is to try to relate this back to here so that I can actually try to observe and guess what is the expression of this function f. For this that I have, what I'm going to do is, for limit of n tends to infinity, 1 over n I'll let it be because here I have a 1 over n. And for this, I'm going to break this up into a few different parts. This divided by this is going to be cube root of 1 divided by the cube root of n, and then this divided by this is going to be cube root of 2 divided by the cube root of n, and all the way until the last term, which is the cube root of n divided by the cube root of n. So I'm suspecting that all these terms here are going to be related to f of 1 over n. So what if I were to try to rewrite this as limit of n tends to infinity of 1 over n of this cube root of 1 over n. And this I can also rewrite it as the cube root of 2 over n. Okay, now I have a 2 over n, and all the way until the very last term, it is going to be the cube root of n over n. And that corresponds to this, which means that from observation, I can see that my function fx is going to be cube root of x. So when x is equal to 1 over n, it is going to be cube root of 1 over n. And when x is equal to 1 over 2, it is going to be cube root of 1 over 2, cube root of 2 over n, and so on. Which means that now I know this can be approximated by integrating from 0 all the way to 1 of fx dx, which is actually integrating from 0 to 1 of fx is cube root of x dx. So this can be integrated by rewriting this as x to the power of 1 over 3 dx. Integrating this is a simple integration, x to the power of 4 over 3 divided by 4 over 3 from 0 to 1. So this is going to be equal to 4 over 3. If I were to take it out, it is going to be 3 over 4. And substituting 1 in, it is 1. Substituting 0 in, this is 0. So my answer is just simply 3 over 4.